Hello and welcome to another tutorial. So this time around we are going to be adding in animation support to the Behaviours package. So this is going to be split across two parts. So in this first part what I'm going to focus on is the core infrastructure for the animations and also getting things up and running as far as using them with our interactions. And then in the second part what will be done with that is integrating that into things like our behavior trees so that we can have them fire off an animation. So that's sort of the plan for this. Now, if you are wanting to dive into this, I do have 3 links in the description below. The first is a link to the project as it is at this particular point in time. So if you're wanting to follow along, that's what you want to grab. The second link is to the project as it will be at the end of the video. So if you're wanting to just jump to that completed version at the end of this. And then the third link is to the overall AI package. So that's one where if you're wanting to just bring this into your own Unity project, that's what you're after for that. Now keep in mind with that project, there's regular updates that I'm doing to that. So there may be additions there beyond what's currently shown. So let's dive on in with this. And so what I want to get set up is a few things, because if I wanted to just play animations, things like that would actually be pretty straightforward and easy, because we've already got connected up on our AIs. They already have an animator on them if we take a look at the mesh. So they've already got an animation controller there. So we could easily kick off animations, and I have connected up a couple of additional ones. We have this behaviors layer. So I won't dive into the specifics for that. And wow, zooming just, okay, there we go. So this has 3 separate ones here. I have hooked these up intentionally via 3 different methods so that we can see, okay, activating something by setting a parameter, activating something by setting a trigger, and just directly playing a particular state. So I wanted to illustrate all 3 of those sort of main ways that we might work with this. Just because what I want to set up is something that is a bit of a bridge between our behaviors and the animation controller, because the animation controller could be, as in this case, it's located on child, or it could be on the parent, depends on the particular setup. So I want to have something that sort of wraps around a bunch of the behaviors so that we have a bit more of a generic way of actually working with this. So what I'm going to do to begin with is in our character core, because that's where this sort of fits. I'm going to create a folder here, and this is going to be for our animation setup. So a couple of things that I want to create here. One thing is I want to have an animation interface. So I want to have an IAnimationInterface interface because we're following the process and structure that I have for a lot of this project, where we have interfaces and all of our communications happen through that, so that if you want to heavily change the underlying code, then you can. You've got a dedicated interface that you can sort of plug into. So we'll have our animation interface, then we'll have a concrete implementation. And this is, I'm going to call this our Animator Bridge. Now, the other file that I'm going to create is, because I want to do a couple of little things that require me to get callbacks and get callbacks generically when an animation gets to a particular point. Those callbacks are only going to come to the object that has the animator on it, which in our case is the mesh. But I kind of want that to be being sort of bubbled up essentially to the parent object. So what I'm going to do is I'm also going to create a script here, and its purpose is going to be to do that. So this is going to be our animation event relay. So, okay, those are our three key sort of main ones that we want to actually have. And we'll zoom in quite a bit and start to actually populate these. So I'm going to do the relay first because the relay is very, very simple. So this, we're going to give it an add component menu. And this will be under character. And we'll call this animation and Animator Bridge event relay. Like that. It's not going to have a start or update. What it will have is a serialized field of, and in this case, our Animator Bridge. So this is the one exception where I wouldn't use the interface, and that's because I want a direct connection there. So linked bridge, because this is very type specific and very specific to the bridge itself, so it doesn't make sense to have this go through the interface at this stage. If I had a use case where that was different, then I could look at opening up the interface, but for now, I don't think that's necessary. So this is going to have our on animation start, because what we're going to end up connecting up, and this will do via code, is a couple of helpful little functions here that what their job will be is when we tell it to play a particular animation state, these functions will get called and then they'll notify the bridge. That, and we'll have our start, and there will also be a finish. So on animation finish, and I'm intentionally keeping the names here identical, and I'll even keep those interfaces identical. The idea being that then on the bridge itself, those functions exactly match, so that if I had the animator on that parent class, I wouldn't need the event relay. I could just use the bridge, no code modifications. So keeping those interfaces with the exact same names, exact same parameters, just makes that a lot easier for us. So that's good. Now the bridge itself, that's going to implement our IAnimationInterface once we have it set up, which I will change that. And that's going to be a locatable service. That's good. Animator Bridge is going to implement that. We'll have to populate a few things. We will get to those. Firstly, I want to add in the Add Component menu. So we put this again under Character, and this will be our Animator Bridge. And I'll put that as animation, like that. So, okay, so far so good. So I want to focus on the actual interface itself. Now, with the interface, it's going to be a fair bit more complicated than if we were just directly talking to the animator. That's kind of intentional because this animation interface, we're expecting what it's linking to be doing a lot more. We're expecting it to be taking responsibility for when states are ending and communicating that back, keeping track of things. So there's a bunch of stuff we need to actually set up for this. So one of the things is I want to be able to configure in the inspector a and this will be our system.serializable. I want to be able to create an animation request. So this is going to be the main way that we communicate, hey, I want you to perform a particular animation. So what we'll have with this is a few parameters, because one way we could do this with a request is we could actually just provide a state name like that. The other options is we could be providing Boolean parameters, we can provide integer or float or triggers. So there's a lot of different parameters we could provide, and those are identified via name. So what I'm going to do, because this is something where we're going to have lots of different parameter types, I'm going to have a system.serializable. We'll have a public abstract class, and this is going to be our animation parameter. That. Now, what we're going to have for it is the only member it's going to have is an actual name. So that's going to be the parameter name. Then we can define our individual ones for the different types of parameters. So I have another system serializable. And this, we would have a public class Boolean parameter. And that Boolean parameter is going to inherit from animation parameter. And all it has, public bool value. So we'll do similar for our other parameter types, because as well as Boolean, we will have integer, have float, so okay, we've got Boolean, we've got integer, we've got float. I want to have my trigger parameter as well. The cool thing with the trigger parameter is it doesn't actually have a value, because triggers, we set or reset them. So, okay, that's good. What it means then is we have a list here. So we'd have a list of our Boolean parameters, and that's like that. We'd have an autocomplete is helping us out. Float parameters as well, and trigger parameters. Handy. So this gives us a single encapsulated class that has all of the possible parameters we might need to be sending to kick off a request. And not all of these will need to be populated. It's a case of only the ones that we actually use are populated. So that's good. Final little thing here to set up that would be helpful is our animations could complete for a particular reason. So an animation completion reason. So for now, we're going to have just finished and interrupted. There may end up being other ones we identify, but for now, those are the two main ones that I've run into. So, okay, in terms of with this, we've got a few sort of particular ways of working with this. So I think it would be useful to have just general things for pushing Booleans. So we'd have stuff like push bool, and then we provide our value. I want to have similar for our integers. Make sure that's naming properly. The autocomplete does a generally a pretty good job And there we go. After a couple of times, it picked up on the sort of naming convention, which is good. Saves typing. So we have push options for if we're just pushing individual parameters, because that could be useful. We're going to have our send trigger. Now that just has a name. There's no value. It does have, though we want to have a reset trigger. Again, needs the name. Setting a particular state. All that specifically in state name. So these are sort of the lower level methods for interacting with stuff, but then I want the higher level method. So I want to be able to essentially issue a request. And when I issue a request, I want to get an ID back. So this is something where I think it's perfectly fine for us to use something like an integer for this, because it's going to be keeping track of how many requests it's issued. So we can just have a counter that increases for tracking that. So I want to have issue request. So that we'd provide animation request. So this is our request data. That. Now this, I want to have a callback that can run when it's actually finished, but I don't want that to be mandatory. So we'll have an optional on here that will be a system action. Now it gets the unique ID and that completion status, because that's useful for it to actually know. So this is our in on finished callback function, but we'll default that to null. So I'm just going to bring that down here. That. Actually, it can stay on the same line. It's fine. It's the one downside with zooming in. It does mean that it takes up a lot of space. So, okay, we can issue a request. The final thing that I want interface-wise is a cancel request option. And with that, I would just provide a ID, and this will be our request ID, like that. So that's good. It's a locatable service, has all of our interfaces there. Now the main focus, and most of where I work is actually setting up this bridge. Now, what I'm going to do with the actual bridge here is a few things. So in the actual bridge, I'm going to take these functions and bring them over. The reason being is that if I auto added things, then what happens is you end up with stuff being reordered, and that actually I find really annoying. So this is our IAnimationInterface. Do an end region like that. It's going to bring all of these in. So those become public. Now the actual logic for most of these is going to be pretty straightforward. So it's going to be very, very little sort of logic that we actually need for this. So this is going to have a serializable field, and this will be our animator. Actually, it doesn't need to be that. I can just make that serialize field, animator, and that will be linked animator. So that's good. For a lot of these things, like pushing of bools, stuff like that, we can just implement them right now because the functions are very straightforward. Same with our integer. Same with our float. So those interfaces are very straightforward. Our triggers are also very straightforward. So we'll implement those while we're at it. So just have to do set trigger. And then similarly for the reset the trigger. So those are quite straightforward. Setting the state is also a pretty straightforward one, because what it does is it just does a linked animator, tell it to play, and we give it the particular state. Now these ones, for issuing the request, we will get to those in a moment. There is quite a bit that we need to do for those, so I don't want to dive straight into that, because there's a couple of bits of sort of setup logic that I want to also implement here for this. So this has links to the animator. Now, what I want the Animator Bridge to also handle is if we have multiple variants for a particular animation. So when something comes in and says, hey, play this particular animation, if we have 10 different ones, I want this to be able to actually pick particular ones, and we could add further logic later down the track for weighting those if we wanted to. So I want to have some actual logic here so that only this needs to care about the actual names of the particular animation clips. So what I'm going to do is a couple of things. Firstly, I'm going to have a system serializable, and this is going to be an animation set. So call this our animation bridge, animator bridge, and animation set. That. So what this is going to have within it, well, that I want to have the public string, and this is going to be the actual name, essentially the external name. So I'm going to call this external name. But then it needs to have our individual entries. So what I'm going to do, because at this stage there's not any additional sort of logic I have for the particular individual animation clips, but there might be later down the track. So if I have it already grouped within a class now, then it makes my life a lot easier later on. So this one is, our Animator Bridge animation set. It's almost a tongue twister. Entry. So this will have a public string, and this will be our state name. So that's the actual name used within the animator itself here. So that's sort of how those names map. So then what will happen is this will have a public list of those, like that. So it can use that for actually picking between the particular ones. And then what that will mean is down here, I'll have another serialize field, and this is our list of animation sets. I'll actually change the naming of that. So that's our animation set, so we can hold all of that data. And because it's kind of useful, I want to have the ability to just indicate, okay, what's the default sort of idle state? Now, I think later on, there's further stuff that could be doing in terms of, okay, indicating what layer these particular animations get played on. At this stage, there hasn't really been the need for that because I've got everything that's sort of more behavioral grouped into one specific layer, but that is something that I could add later on. And because it's been grouped like this, that's going to be a lot easier to do. So, okay, that's good. Having these as a list isn't a super useful way of actually working with it in code. It's great for easily accessing it in the inspector, but not great for working with it in code. So what I'm going to do is I'm going to create a dictionary, and this is going to map from a string to a list of our Animator Bridge, so not our animation sets, but our animation set entries, because this is a much easier one for actually working with. Not null, I want that to be new, because I will actually be populating that early on. So, okay, so far so good. I need to keep track of our next request ID. So that's one that I want to have stored here. So I want that. So, okay. What I want to do then is in awake, there's a couple of little things that I need to do. So in awake, well, one thing I need to do is register ourselves with the service locator. So with that, I need to register, and what I'm registering is as an IAnimationInterface. Register this, and the context is the game object that we're on. So just make sure we do that registration early on. Then we're going to build up our map. So all I need to do for that is we go and actually say here set in animation sets, and then our animation map. What I'm going to do is I'm going to add, so under set and its external name, that becomes equal to set animations. So nothing too complex to that, but it just builds up the animation map. The bulk of what I want to actually add in here is, so I mentioned having those automated hooks for when a particular animation is actually starts playing when it finishes playing, that was something that I wanted to do. So I'm going to set up the code for that. Now this is not code that I fully developed all myself. This is one where it's based upon an external source. So the first thing I'm going to do is I'm just going to bring across a link for crediting that, because they came up with the solution for this and it's actually really, really cool. So full credit to them for this setup because it made my life so much easier. And event notifications. So what I do is I'm going to loop through every single clip. So from clip index is 0 to clip index. And what I do is I go linked animator, runtime animator controller, and that I can access the full set of animation clips. So that gives us a way of actually doing that. So that means I can pull out the animation clip from that does end up being a little lengthy. So like that. So I can pull out our animation clip. Then what I do is I add in our particular events. So we have an animation event, and this is our on start, I'll call it start event. So we create a new animation event. Then we configure it. So the start event, its time, this one's easy. The time is 0 for it. The start event, the function name, well, this is where we use this exact name we set up here. So that's why the names needed to match. So we have on animation start. We then provide a string parameter, and that string parameter is our animation clip, clip.name, like that. So we know exactly what particular clip has finished. So that's good. Now what I can then do is I can link that up. So our clip, we add an event like that. So that sets up our start event. Our end event is quite similar. So this is going to be our end event. We need to make sure the name matches. So for consistency, I'm just going to call this finish event. Now, the time for this, your general approach might be to go for that just being clip length. However, there does tend to be an issue if you have an event that is at the very last frame. That tends to not fire. So what I'm going to do is just back it off by 1 frame, essentially. So we can do that by getting our clip and our frame rate. So that will, 1 divided by frame rate. So that will just allow us to back it off a single frame so that it should then reliably actually fire. So that should be good. So, okay, so far so good. We're starting to now get to our more full-on ones. And once we've got these up and running, that's actually pretty much all of our logic. So, okay, I might have a current request in progress. So what I'm going to also keep track of up here is an animation request, current request. Just because if there's already one in progress, I need to actually handle that. So if our current request is not equal to null, then I want to cancel request, and that would be next request ID -1. So, okay, that's good. That allows us to handle that logic of it. What I would then do is, okay, issued ID is going to be our next request ID, and we update it. I know I could do that in a single line, but the code is a lot clearer like this, unless you are, super familiar with the difference between doing ++ variable name versus variable name ++. So I prefer it just to be obvious and straightforward. So that's good. I also need to keep track of this callback, because that's something I want to keep a copy of as well. So I'm going to go up here and store it as well, like that. So, okay, we update the ID. We're going to update our callback so that that's stored. We'll store our request as well. So our current request, like that. So that's good. We're storing the key bits of information there. That issued ID is what we'll return. Okay. So first thing I want to do is I need to handle the actual animation state if a particular state has been provided. So what I'm going to do is I'm going to loop through here. Firstly, it's going to be really handy for me to know what particular clip I kicked off and what state was associated with it. So I'm actually going to have some extra logic up here. And what this extra logic is going to be is going to have a selected animation or selected state. And that selected state, I'm just going to actually default that to null as well. Okay, so first thing we do is pick the animation F1 is provided. So selected, actually that should be, I'm going to call that selected animation clip because that's actually more accurate for what's actually happening. So our selected animation clip, clear that first. F, we actually have valid one provided in the state name. Then I'm going to try and find the particular one to actually be using. So I want to keep track here of my Animator Bridge set entries. This is our candidate animations. So we will new that because what I'm going to do is then actually find particular ones. Actually, I don't need to new that. That can be like that. So I would do F animation map, sorry. I'll do a try get value of our request starter's state name. And then within that, we have out candidate animations. So if that was successful, so we found a matching state, and if we actually have entries there, because we might find the state but have no entries. So if the count is greater than 0, then what I would say is our selected animation clip is our candidate animations. We do a random range. That. So up to our count, and from that, we just grab state name. Technically, I mean, it is a state, so actually rename it again to selected animation state. That is more accurate for the particular name of it. So that's good. So that allows us to pick a particular state. If we actually did do that, so if string is null or empty and not that, so our selected animation state, if it is not null or empty, then all we need to do is not push state, set state, like that. So this is where we start using those push and other functions. So we'll apply the particular state. Then for our parameters, it's actually even easier. Parameters, what we have parameter in request Boolean parameters, and we just do push bool, parameter name, parameter value, and then unsurprisingly, we're going to have same logic for integers, floats, and triggers. So this time we're looping over integer parameters, and we do a push integer. This one we're looping over float parameters, and we do a push float. This one we're looping over trigger parameters, and we do set trigger or send trigger with a particular name. Setting the state if we found it. And then here we're pushing our parameters. This just allows us to fire off an animation with all of that data. So that's good. That looks all right. For this cancel request, we need to set up. So obviously, if we don't have a current request, so if that is null, then there's nothing to do. Now, we don't do anything with the ID at the moment, but longer term we likely will. Now we're going to have a couple of areas where we might need to do cleanup. So in this case, this one is I'm going to create a cleanup function. It doesn't exist yet, but it will soon. And I just will provide the completion reason, which for cancel, we're going to generally flag that as being interrupted. So then our cleanup, which gets the reason. Now, what the cleanup does is, okay, well, if we have an onFinish callback, then I'm going to run it with the request that was just finished. And what I'm going to then do is provide that reason. And actually, I might put this as a ID just to make sure we're actually doing this correctly. Because that would be, while we're not using the ID really at the moment, that is something that it would be bad if we got that wrong. So we're going to flip that around as well. I think it makes sense to provide the ID first. So that's good. We also null out that callback so that we're not actually able to be working with it anymore. Really, the main goal is to avoid keeping any stale data around. Now, when we clean up, I want to always return back to our idle state. I'm going to clear our current request. I'm going to clear our selected state. And parameters that we have an obvious way to undo them, I'm going to undo them. So our bool and trigger ones, I can undo those. Can't really, I could be adding and getting of values for the float and other ones, but those there's less of a need to. So I think with this, what I will do is just undo these ones. And we reset trigger. Now this can obviously only do that if we have a current request. So later on, we might find that there are use cases for undoing things like a float or an int. I don't see a lot of use cases for that at this stage, but it is something that if we did need to do that, that is a thing we could actually add in support for. And we could even end up adding in later on some low-level logic here as a common parameter for these to indicate whether they get undone on interruption or cancel. For now, I'm just going to assume that bool and trigger ones should, because generally they actually should do that. But it's just handy to have that there as sort of a default sort of setup. So on animation start, there is nothing we need to do. In our on animation finished, there might be. So if we have an on finished callback, so if that's valid, and we have a current request, now should be impossible for only one of those to be valid, but just to be certain, I'm going to check both of them. And what I would check is if the state name is equal to our selected animation state. If that is, then we know we've actually finished it. So I can say on finished callback function. We provide it with the request ID, and the completion reason is that it finished. And then we do our cleanup with the request ID, clean up with the next request ID -1, and what the finished reason was. So actually that would call our onFinished twice. So actually we can just do our cleanup. So that's the majority of what we need to set up in terms of code. There is some content that we need to get set up, and then we'll hook things up to our interfaces, but that gives us our sort of core logic for the code setup. So the next thing I'm going to do is just check to see if we've got any errors. So is grumpy at us about the request one, which we do have that implemented. Let's just double check that we didn't miss anything with that. What is it grumpy about? It thinks it doesn't have... Oh, it's because I didn't make them public. Go. So those are public, so Unity should be happy now, which it is, so that's good. So what I want to do, firstly, is update our prefabs, which we do have a few prefabs to update. But in terms of what the update that's needed is, so on our parent class, that's where we would add in our character and our Animator Bridge. And this is where we define our animation sets. So we have 3 ones here that need to be defined. So I'm going to create 3 separate ones. That error seems to be an issue with the current version of Unity, so that's fine. So couple of different ones of how I want to refer to these. So the external name is the key thing that matters here. Now that external name for this one will have a jump. Actually, we'll have celebration. We'll have reach, and we'll have gesture. So these are what our external facing names will be. Then what we do is celebration. That actually is And we'll match the case exactly just to be on the safe side. We'll have reach forward. So if you're looking for animations, in particular ones for humanoid characters, I would highly, highly, highly recommend Mixamo. It is free, and there is a huge range of animations there. It's a really, really, really good setup. So very strongly recommend it. So, okay, that's our Animator Bridge. That's going to end up going on all of our base prefabs. So I'm actually going to copy that component so that I can then go to our state machine ones and open that prefab. And we'll just make sure that's all good. Yep, it's not in there currently. No. So paste component is new. That's good. We'll update our standalone ones as well. Just want to make sure everything has support for that. And then our state machine ones, do the same thing. Next component is new, so that's good. Then what we link up is on the actual mesh. That's where we add in our Animator Bridge, and we have to just link it to the parent. That one we don't want to copy because that's going to not work particularly well because it would be linking to the wrong thing, or be trying to link to the wrong thing. So we just link these up on everything. And that way all of our AIs will have support for being able to actually play those animations. And then there's not too much further that we need to actually add to be able to make use of those. Now, at this stage, I'm only going to demonstrate adding in usage of them for our interactions here. That's something that then later on, in the second part of this, I'll show setting up particular behaviors for that. But what we've now got is all of those animations connected up. We want to actually make it possible to be able to be using those. So, a couple of things I want to do to actually get that set up is I want to add this, essentially the support into our interaction system. So in our interaction system, where this would go is we have our actual interactions. So we have our simple interaction. That's going to need some additions to it. The other thing that we are going to need to update, where do we have this? Can't remember where I said, oh, interfaces, of course. That makes sense. So our interaction performer, that's going to be the method we use for accessing our actual animation interface. So it means that any interaction performer is now going to have to implement this animation interface. Well, the property would actually retrieve it. So animation interface, like that. That's going to allow our simple interaction side to make some assumptions, which will be really handy. So firstly, what I'm going to do is I'm going to set up so we have access to an animation request. Now this won't be mandatory, but this will be something that can get used. So completely optional thing that we might make use of. What I will keep track of though is just in case we have actually issued an animation request, I will have current animation request ID, which I'll default to -1 because we don't want to be able to easily know that we don't have one in progress. Then in terms of where this gets kicked off, well, when we begin the interaction, so we have our onBegan interaction. So this is kind of the perfect place to do this. So what I would say is if our performer has an animation interface that's valid, and we actually have animation data that's valid. Because we might not, but if we have animation data, then what I'm going to do is say current animation request ID, and we'll do in performer issue request. So that's something, sorry, in performer animation interface issue request, and then we'll provide our animation data. Now that might be handy to actually make it so that that animation data, we can check if it's valid. So, because it's a class, so it could be populated, well, it could be constructed, sorry, could be constructed but not actually have valid data in it. So I'm going to create a bool here, is valid. And all this is going to do is, okay, well, if essentially anything is valid, the string for the state name is not null or empty, then it's valid. And essentially, if any of the parameters are valid. So, okay, we can store here, so for each parameter, yep, we will loop through the Boolean ones first, and this can use a similar check. So if not string is null or empty parameter, then we return true, and that'd be parameter.name. And we do the same logic for every single one of these. And because that we have that common abstract base, it means that we don't need to restructure that. And trigger parameters. So we just make sure that there is actually valid animation data set up, because it might not be. So if that's not null and it's valid, then we'll issue the request. Now, when we've completed the interaction, well, if our current animation request ID is greater than or equal to 0, and we still actually validly have an animation interface on that performer, then I want to actually tell it to cancel it. Because these could be looping animations. So if it's a looping one, we don't want it to continue looping. And we do the same logic for if we have cancelled it. But what I'll also do is current, we just invalidate that at the same point in time. Do the same thing here if we abandoned it. It just ensures if we've completed it or abandoned it, that we're leaving it in a good state. Now, because we have made that animation interface a mandatory thing, what we will find is a bunch of things are likely going to be grumpy at us, which is okay. So our two base brains are going to be grumpy, so that's okay. That's expected. So we have our IAnimationInterface like that. We need to put the same thing in our state machine brain base. And we need to populate that. So we do the same logic that we do for all of these other ones. I'm going to space this out a little bit because it just keeps it neater, and we can group the particular ones. So we use our service locator to our async locate for our animation interface. We just populate that. Just like that. But we search on the game object and we only search local. The brain base for the behavior trees will need the same. We'll put the same logic here. Those are already broken up a little bit to make it neater. So that's good. Let's just see if any others are grumpy at us. Not surprisingly, the GOP brain base is to be expected. It's going to need the same interface. It has the registration ones. Going to populate that in there as well. And it'll have the same sort of logic in terms of needing the interface like that. Go brainy base gets the same thing. See if anything else is still grumpy at us. No, so that's good. So less things are grumpy at us, always a plus. So that's looking pretty close to everything we really need for this. We've got all of sort of the core bits there. We should be able to connect up our actual animations then. So what I'm going to do is I'm going to go to the interactables here, and I'm going to edit things like, so our microwave one, I want to find the prefab for that, and I'm going to update the prefab, and then we're going to make hot drink. We'll have our animation data here. So we've got our different ways of requesting the particular ones. Now I do need to refresh my memory on what I actually named the particular entries. So we have celebration, reach, and gesture, the different option ones that we've currently got. So I will go for gesture as being the particular one we want to make use of for this. So if we're making a hot drink, we'll put that as, and we had the different ways of playing these. So gesture was one that it can just directly play it, like that. Do the same for heat food. So that's good. Reach is, I believe, a trigger. Yes. So I'm going to actually gesture. I might change the microwave to reach, makes more sense. I'll use gesture with the TV. Actually changes how these work. Okay, so now that I know the names of the particular ones, for the microwave, so heat food and make drink, I think the reach makes the most sense, and that's a trigger. So we're going to add in a trigger parameter. Let's call it reach. We'll do the exact same thing for making the hot drink. That's good. The TV, I'm going to set up it as well. So for all of its interactions, I'm going to make them just do gesture. So this one, so reach was controlled by triggers. Gesture, we just play the state directly. So these will all be set up like this. It's good. Now, the bookshelves, I also have interactions configured on them. And although it's going to be a particularly odd one for them to be doing this, for the Boolean parameters, because I want it, the last one that we've got is jump, which I believe was celebration. What did I call it? At some point I do want to change these to having sort of a drop down for using the name system. Okay, celebration was the particular one. So we'll go to our bookshelf and our different interactions. So we're going to our Boolean parameter, celebration, we set it to true. And we'll do the same thing for browsing aimlessly. Set that to true. So in theory, without any behavioral changes, all of these AIs should play an animation when they're interacting with any of the particular things. So let's find out. It might work, or a whole bunch of things might break. Hopefully, things working. So, okay, we did get ones complaining that the bridge, the linked animator had not been populated. So let's go to our AI prefabs and make sure we have those properly set up. I suspect, yes, I did not link that up on any of these. So I'm going to go to each of our prefabs and link up their respective animators now. So that will clear that error. Okay, so that's all of the animators linked up. So now let's clear that and let's try that again. Definitely tried to interact with the animators, so that's at least something. Now this time, you can see gestures were performed. It did get here and say celebration does not exist. So what's happened is it's tried to set that particular bool, and if we go to what it was needing to do for those, so we'll go back to our smart objects. And so for celebration, that was actually needing to, that was our jump. So it actually needed to be is jumping. So that was our bookshelf. So that was is jumping. Do the same for this one. So the gesture played okay, but the other ones didn't work. And our microwave, that needs to be changed to is reaching. On the plus side, it does give a specific error that makes it straightforward to track it down. That's good. That should fix all of those. Let's try that again. And we should see the different animations fire. So there we go. Saw a reach one, They're excitedly jumping as they read. This one's going to head over here and gesture. So we have our different animations hooked up. And that was just our behavior tree based sort of test same. I should be able to go to things like of our state machine one for these AIs, and it should also just work. There shouldn't need to be anything different because the logic is controlled within the interactions itself. And we can see the animations are firing. So that's good. And we can check our standalone ones just to make sure those are also working. So that. So those are moving. Animations are playing. So that's good. We'll check our state machine standalone one just to make sure we've got everything covered. Those are running and the animations are firing. So that's good. We have our setup going so that we've got our generic animation interface that we can use for a lot of different things. We've integrated that into our interactions. So the actual objects are controlling what parameters get set, and then how the AIs interpret those is really down to how the animations are configured, which the cool thing with that is that then empowers your animators to actually manage and control how they want those things to look. They get the data coming in, and we make sure that's standardized, and they can go to town with that and make it look how they want, which is great. So this is it for the first part of this. As I said, in the second part, we'll be looking at how we integrate this with behaviors as well, and so that we have things like behavior tree node to specifically play particular animations. That's going to be the next sort of stage of what we get up and running. But dive on in and experiment with this and see what kind of things you might want to add to it. Thanks, folks. Hope you found that interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, there are 3 links in the description below. One is to the code, as it is at the start of this project, at the start of this video. Another is the link to the code as it is at this particular point. And the third is a link to the completed package. If you're looking for other animations for the project, then Mixamo was the place that I recommended for that. Those are currently freely accessible and really good range. Highly recommend it. If you have any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time, bye.